So, hello guys, Happy New Year. I'm Kumar K, your favorite DSA teacher when it comes to solving hard and thin DSA problems of top tech companies, OA rounds, online assessment rounds, which students fear a lot. I will remove that fear from you, don't worry. And also, we are very much interested in solving competitive programming, interesting CP problems. Guys, coming to for our love for DSA, I have All India rank 12 in Google Code Jam 2021 and All India rank 4 in the recent Facebook Hacker Cup. Also, in the past, I have worked at Amazon and Mia.net as a software engineer. Despite being from a Tier 4 college, I cracked those offers off campus. Today's session is going to be very, very brilliant. Why? Because we are going to solve tower research OA problem. These days, many students, are giving the OA round of tower research, and tower research comes under the category of HFT firms which pay the highest. So the CTC is very high, and obviously their DSA questions are the hardest when it comes to the OA rounds. So today's session is going to be on a very hard question. It requires lots of prerequisites, but hopefully my audience will be able to understand most of it, as I will try my best to explain this hard question to you. Now, guys, one more great thing is that we already have the first selection of the new year in our awesome cohort. So Anukriti is my personal one-to-one mentoring and daily life training student of the cohort. She has recently cracked the offer from Microsoft, and it's a very happy news. Okay, happy new year news for us. Obviously, guys, Microsoft asks the hardest unseen DSA questions in their OA, and tricky problems of DSA these days in their interviews. So she attended all the daily life classes of hours of DSA OACP, and she practiced from the course also very well. She used the mentoring, LinkedIn, resume training, referrals, everything in the best way possible, and she has generated this brilliant result. Okay, so I am very happy to see that daily hour students are getting top level of selections. So don't fear DSA, start loving DSA, and then DSA will love you back. Now, if you scroll below in my LinkedIn post activity, we can see that just a few days back again, Sukriti Sinha cracked off campus offer from Amazon despite being a 2025 grad. So congratulations to her. And just few days back, once again, one more student of mine, Harini, cracked the off-campus offer from Amazon. And like this, we have countless selections from different companies. Okay, so guys, if you are someone like who is maybe in the college or maybe working professional, if you want the best live DSA training in the country by me, and you want to also prepare for OA and CP, you want to master system design, full stack development, you want referrals, you want one-to-one mentoring by me, and you want to get selected, then you can check the special new year offer which we have. The link will be in the description. Also, we have many more free facilities and features, so make sure you check the things in the description. Now let's move towards the question, which is very interesting, by the way. So guys, the question is this one: tower research OA, CTC 85 lakhs. Okay, obviously very hard questions, only then you will get 85 lakhs in your bank account, right? So anyways, some fun apart, you are given an array of size n. You are allowed to do the following operation: select any index I and change the element at index I to any non-negative integer. Find the minimum number of operations required to make sure all the subarrays of size k in the array have their XOR value as 0. So guys, what is the question saying? Question is saying that we are giving an array of size n. Okay, clear. Each subarray of size k, each sliding window of size k should have their XOR as 0. And if the XOR is not 0, you have to optimally change the value of some elements so that each subarray, each sliding window from the start till the end has their combined XOR value as 0. So that's the question for us. Now, the thing is that this is a very interesting question, and I have broken it down in the simplest steps possible to solve it. The main solution lies in the constraints. You can see that the n is also small, and the values in the array can only be as large as 2 raised to 6. So that gives us a big hint, right? But let's discuss some cases. So guys, first I will take the case 1, 2, 3, 4. Okay, so Ram, God is very important. Without God, we cannot do anything. So let's say, guys, this is an array given to you. 1, 2, 3, 4. Okay. This is an array given to you. And let's say k equal to 3. K equal to 3 means what? That this subarray XOR should be 0 and this subarray XOR should also be 0. All the subarrays which have the size 3, their XOR should be 0. So which is the first subarray? First subarray which we consider of size 3 is this. And which is the second subarray? First subarray is this. Second subarray will be 2, 3, 4. Now check guys. Is the XOR 0? So 1 XOR 2 XOR 3 is indeed 0. It's indeed 0. Okay. But 2, 3, 4 XOR is not equal to 0. 2 XOR 3 XOR 4 is not equal to 0. So what can you do? You can do the change operation. Guys, you read in the problem, right? You write in the problem statement that if all the subarrays of size k are not having their XOR as 0, you can change some elements. Now it depends on you which elements you change. You have to change the minimum number of elements. So here at least one element you have to change. So guys, what we can do is that we can say that this element should become 1. So guys, in one operation you can solve this question. If you change this element to 1, the new array will be 1, 2, 3, 1. 1 to 1 mentoring. So this subarray of size 3 is having XOR 0 and 2, 3, 1 will also have their XOR as 0. So that's why hopefully everyone understood the question who is watching the video is that if our array is 1, 2, 3, 4 and you want to make sure that all the subarrays of size 3 have XOR as 0, change the last number to 1. And changing the last number to 1 solves the question for this simple test case. Now, let's start the enjoyment. So how will we enjoy? We need to know some basic XOR concepts. If you have not studied about XOR, I will just prompt you to Google search or search on YouTube bit manipulation and XOR and try to understand the basic concepts of XOR. XOR is nothing but just it's very very close to addition of numbers. Okay, so let me show you some examples. Like in binary numbers, in binary terms speaking, 1 XOR 0 is always 1, 0 XOR 1 is also 1, 1 XOR 1, whenever two numbers are same, the XOR is 0. 0 XOR 0 is also 0. Okay. This is for the binary. And similar type of rules will be followed for decimal also. So let me take any decimal numbers x and y. If this rule you should always remember, if x or y is equal to 0, it means that x is equal to y. Always remember, if I say that x or 5 is 0, it means x is equal to 5 because only two same numbers can result in a XOR as 0. Okay, this property, theorem, whatever you want to call it, please remember it. Okay, next thing, if x or y is z and it is fixed that x is not equal to 0, y is not equal to 0 and z is also not equal to 0, let's assume that. Okay, all are positive. Let's say all x, y and z are just greater than equal to 0. Then you can shift this x on the right hand side and you can say that y is nothing but z or x. Okay, these basic properties, if x or y, we represent this sign as XOR. If x or y is z, then you can say that y is z or x. Okay, these basic properties if you know, guys, then we can solve this question. So now let's move towards the brilliant solution of the problem. And now I love teaching DSA. I'm telling you the truth. Whenever I record videos or I teach students, it's the happiest moment of the day for me. So now let's go towards the basic observations and interesting observations actually. Ram Ram. So now, God is very important. Always keep remembering God throughout the day. Very, very important. Never forget God. Now, guys, the thing is that you understood what's happening. So, guys, in a grand scheme of things, let's say this is my array A1, A2. I don't know the exact numbers. Let's just assume that all the numbers in the array can be what? They will be from 0 to 2 raised to 6. Guys, do you know what is 2 raised to 6? 2 raised to 6, I think it's somewhere around 64. So the numbers in the array can be from 0 to 63 only. That's a big hint to the solution of the problem. So let's say we are given these numbers in the array B1, B2, B3, B4, B5, like this. till B10. Now, what will be the solution for this problem, guys? Let's say k equal to 3. K equal to 3. This means what? These three numbers or values should be 0. Then these three numbers or values should be 0. Then these three numbers or values should be 0. And so on. The last three numbers or values also should be 0. Guys, yeah. And if there was a B6, then you can say that these three numbers or should also be 0. So basically everything should be 0. So guys, I hopefully by now you have understood that you are given an array of size n for all the subarrays of size k. You know, they are going like this. Not notorious Google Meet or naughty Google Meet. So all the subarrays of size k, you know, na? First this subarray, then this. It's a sliding window of size k. All the sliding windows of size k should have their XOR values as 0. So do the minimum number of changes in the array so that this becomes true. So how will we do that? How will we solve these hard unseen DSA problems? If you just do popular DSA sheets, you cannot solve it. But obviously, if you are practicing many hard unseen variations from many platforms over a long period of time, then you can do it. Or else you can become my student and then also you can do it. Your choice. Now, guys, listen to me carefully. First, we will write the equation. What do we want? We want that B1's or B2's or B3 is equal to 0. Okay. And we also want that B2's or B3's or B4 is 0. So guys, if we combine these two equations, what will happen? B1's or B2's or B3 is 0 and B2's or B3's or B4 is 0. So B1's or B2's or B3, if you XOR this with the B2's or B3's or B4, what will be the value? This is what? 0. This is what? 0. Zeros or 0 is 0. So this whole values or will be 0. But B2 is coming here also and B2 is coming here also. So B2's or B2 is also 0. So you can cancel the B2. And B3's or B3 will also be 0. So you can cancel all these things. Finally, it says that if you want all the conditions to be true, B1's or B4 should be equal to 0. It means B1 should be equal to B4. So guys, the full observation which we have reached till now is that if all the equations are valid, na, for k equal to 3 in the array, the first element should be equal to the fourth element. So guys, hopefully just enjoy life. Don't take much stress. Hopefully you understood that if, in any array given to you, if let's say k is equal to 3, k is equal to 3. So now B1 should be B4. Only then, all the sliding windows of size k will have their XOR as 0. But guys, if you do the same equation management for let's say you say B2's or B3's or B4 is 0, you know that. And you also know that B3's or B4's or B5, you want a 0, okay? And now if you merge these two equations, B3 will cut, B4 will cut, and B2's or B5 0. So B2 should be equal to B5. So guys, if you merge all the equations, do you know what is going to happen? The requirement which will emerge is that this B1 should always be equal to B4. No matter what, or else the question cannot be solved. This B4 should be equal to B7, no matter what, or this question cannot be solved. This B7 should be equal to B10, no matter what, or else this question cannot be solved. Ram Ram. So guys, this we can call as our first cycle. First cycle, okay? So guys, hopefully you can see the brilliancy of this problem, that if we merge all the equations of XOR, we come to know that the first element for k equal to 3, you can see it's a plus 3 pattern. First element should be equal to 1 plus 3, fourth element. Fourth element should be equal to 4 plus 3, seventh element. Seventh element should be equal to 7 plus 3, 10 element. 10th element. So now B1 should be equal to B4 should be equal to B7 should be equal to B10. So this cycle should be maintained. Okay. सो गाइज होपफुली यू गॉट द आइडिया कि अगर आपको अचीव करना है सारे सब एरेज ऑफ साइज के का और जीरो होना चाहिए, तो इसके लिए एक चीज मैंडेटरी है। चेंजेस इस हिसाब से करो कि फर्स्ट एलिमेंट फोर्थ एलिमेंट के बराबर हो जाए, फोर्थ एलिमेंट सेवंथ एलिमेंट के बराबर हो जाए, सेवंथ एलिमेंट टेंथ एलिमेंट के बराबर हो जाए। So you should do changes in such a way such that B1 becomes equal to B4 equal to B7 equal to B10. Obviously, this pattern will change depending on the K value, but it is always B1 equal to B1 plus K equal to B1 plus 2K equal to B1 plus 3K equal to B1 plus till the end value. Okay. Similarly, guys, the pattern will repeat for B2 also. B2 should be equal to B5 no matter what. Make the changes in such a way such that B2 becomes equal to B5, B5 becomes equal to B8. Similarly, B3 should become equal to B6, B3 should become equal to B6, B6 should become equal to B9. So guys, the problem is getting solved. If you fix the first three elements, first k elements, then these all elements are predetermined. Predetermined. What I mean to say is that if you are able to find the first three elements which you should be making up, then these values are fixed. Because B4 should always be equal to the first element, B5 should always be equal to second element, B6 should always be equal to third element, again B7 should always be equal to first element, like this. So if you're able to, guys, can you see how interesting? That's why I love this problem so much from tower research. It's checking your cognitive and IQ in the best way possible. So guys, what's happening? Your creativity is getting checked here. So the thing which is happening is that it is sure that you only need to find the first k elements. Okay. Here the k was 3, right? Here the k was 3, right? Here the k was 3, right? So if you are able to figure out the first three elements, these elements you already know what they should be. Obviously, we need to know the minimum changes in the array needs to be done such that these three elements we have. Obviously, their XOR should be 0. Once you know these three elements and their XOR is 0, the only condition you need to follow is that this number should be equal to B4, B7, B10. This number should be equal to B5, like this. So all the numbers after index 3 are pre-decided. You can calculate what changes will happen in the range 4 to n, because these numbers are pre-decided for k equal to 3 if the first three elements are fixed. So the problem now becomes very very easy. Let's quickly go towards the basic notes which I have prepared for you people. This time I prepared the best notes for you. From the heart, from the love. So lovely people. Let's say k equal to 3, you know n equal to 10, a1, a2, a3, a4, a5, a6, a7, a8, a9, a9, a10. The first condition is this, second condition is this. If you merge the equations a1s or a4 equal to 0 means a1 should be equal to a4. And if you write more equations, you will know that a4 should be equal to a7 should be equal to a10. A2 should be equal to A5 should be equal to A8, A3 equal to A6 equal to A9. So basically you only need to fix the first k elements such that their XOR is 0. Once the first k elements are fixed, rest of the elements will follow the same cyclic order. Guys, hopefully this thing is clear that in the array, if you are able to fix the first k elements such that the XOR of the first k element is 0, then the whole property is getting satisfied. Now just repeat these k elements again and again and again and again till the end, and it is guaranteed that all the sliding windows will always have their XOR of like all the sliding windows of size k will always have their XOR as 0 because we have verified it with the equation. So the question now boils down to fix the k elements. Okay. So guys, let's say we do have some numbers, right? We do have some numbers. Okay. Let's say 51 is written, 52 and 53. Okay. Let's say an array of size 10 is given to us. 1, 2, 3 till, you know, this is the array B. Okay. Now, let me make up some easy array for you now. Okay, this is the array. You know that k is 3. You know that k is 3. You know that k is 3, which is very, very important actually. You know that k is 3. You know that, guys, k is 3. Okay, so you know that your lovely k is 3. So you also know that this will be the cycle for the first element, right? This guy matching this guy should match this guy in the final array to satisfy all the conditions, and this guy should match this guy to satisfy all the final conditions. So you have to decide at a1 which value you can put. Okay, so let's say you decide to put 1. You are saying, sir, I am deciding to put number 1 at a of 1. This means how many operations will it take? How many operations will it take? How many operations? How many operations it will take to fix that? Yeah, let the a1 remain a1 only. Let the a1 remain 1 only. So if you want this to be 1, na, it means this also needs to be become 1. This also needs to become 1, and this is already 1. So here zero operation needed. But to make this one operation will be needed. To make this two, one operation will be needed. And this is already 1. So in two operations, you can convert this a1 to 1. Okay. Similarly, if someone told you that what is the minimum number of operations to make this a1 equal to 1? It is nothing but the total number of elements in the cycle. Total number of elements in the cycle minus the frequency of 1 in the cycle. So guys, total how many elements are there in the cycle? The first cycle. There are total 4 elements. You can see now 1, 2, 3, 4. Total 4 elements are there. Total 4 elements are there. Minus the frequency of 1. So how many times is 1 coming in them? 2 times. So wherever 1 is coming, you don't have to make the change. Other places you have to make the change. So 4 minus 2, 2. Similarly, guys, if I told you a different question, I told you that A1 has to become 5. Then what would be the answer? Total number of elements in this cycle. How many elements are in the cycle if you start at index 1? 4 elements. Minus frequency of 5. How many times 5 is coming in this cycle? Uh, Sorry, 5. Yeah. 5 is not coming at all. So 4 operations it will take. Why? Because you will have to make this also 5, this also 5, this also 5, and this also 5. So hopefully you understood. Now what if someone told you make a of 1 equal to 2? Again the answer is same. The total number of elements in the cycle starting at index 1, 4 elements are there, minus the frequency of 2 in the cycle. How many times is 2 coming? 2 is coming here also, here also. So those numbers I don't need to change. But others, these and these, I will have to make them 2 na, to make sure that the whole cycle has 2, because guys it is decided in the condition itself that once you are fixing the a1 na, once you are fixing the a1, it should be equal to a4 equal to a7 equal to a10. So hopefully you understood this basic formula. Okay, whenever you are fixing the a1 value. So guys, now the problem is pretty simple. Like it has been solved 85%. Okay, you can even say 95%. So guys, basically if you decide to put A1 as G, now see, A1 is already given to us, no problem. But we might want to change it, right? Depending on the need. So if you decide to make you, because you are allowed to change your element to any other index. Sorry, you are allowed to change any index to any other number, right? So if you decide to make your A1 as G, then the total number of changes required is nothing but the total number in the cycle. If you are talking about the number at index 1, then find the cycle of index number 1, which is a1, a4, a7, a10. Total number of guys are there 4. And what is the frequency of G in them? Subtract them, because those elements you don't have to change. Only the guys which are not having the G value, that you have to change in the cycle, right? Because you're making all of them equal to G by declaring a1 equal to G. Because if a1 equal to G, then a1, a4, a7, a10 all need to become equal to G. So you know the minimum number of changes now. Awesome, brilliant. Now what to do, guys? We will solve this problem by a very high level dynamic programming, guys. DPI goals are. So, guys, how will we solve this problem? So, you might not be knowing DP at that high level, but still, I will give you an overall idea. Like, if you have joined my 850-hour course now, there are many problems like this, even from the media.net OA involving DP and XOR and bit manipulation. If I am at index I, DPI goals or DPI goals or should tell me that I have fixed the first I elements. I have fixed the first I elements. I have fixed the first I elements. DPI goals or ka meaning, what is the meaning of this thing? DPI goals or should indicate that you are successfully able to fix the first I elements. And the XOR of the fixed first I elements from index 1 to I is nothing but goal XOR. DPI goal XOR means fix the first I elements and make sure that their XOR is nothing but goal XOR. That is the goal XOR value which we want. So guys, in the question you understood now? If this is my lovely array of size n, guys. This is the index 1, this is the index 2, 3, right? 10. And let's say k is equal to 3. So what do I need to find out? The final answer will be what? dp3 of 0. What is the meaning of dp3 of 0? dp3 of 0 means you were able to fix the first k elements. It means you were able to fix the first three elements. You were able to fix the first three elements and you were able to make their XOR as 0. Guys, तुम ही common sense लगाओ ना. If you are able to if you are able to fix the first three elements and you are able to make their XOR as 0, the problem is solved. Why? Because the fourth element value you already know it is nothing but the first element value. Fifth element value is nothing but the second element value. Sixth element value is nothing but the third element value. And this keeps on repeating. So because these things keep on repeating, now you only need to solve for the first k elements. So basically what I have to do is that I if I'm given an array of size n and the range is k, I need to calculate dp1, dp2 till dpk of 0, dpk of 0. Why? Because dpk of 0 tells me that you were able to fix the elements from index 1 to index k and the XOR of those elements is 0. But guys, the XOR can be something else also, right? So the first index will always go from 1 to k, right? If I call it as dpij, the I will always go from 1 to k and the j will always go from 0 to 1023. Why? Because 1023 is nothing but 2 raised to 6 minus 1. Why am I only going till 1023? Because those are the only possible values of XOR. If you take some elements and you know that each element is from the range 0 to 2 raised to 6 minus 1. You know that each element is in the range 0 to 2 raised to 6 minus 1. Then their XOR maximum XOR value will also be less than equal to 2 raised to 6 minus 1. If you know the XOR concept, you should know this theorem that if each element of the array you can see is from 0 to 2 raised to 6 minus 1, less than 2 raised to 6. So even if you try to find the maximum XOR of a subset of elements or the whole array XOR, the XOR will also be less than equal to 2 raised to 6 minus 1. So the possible XOR values are also less than equal to 2 raised to 6 minus 1. So I'm only doing dpij, okay? So what is the meaning, guys, lovely people? The meaning is that DPI goals or means that first I elements of the array have been selected, decided, and you also know that their XOR is nothing but the goal XOR value which I have written here. Minimum changes required in the whole array to achieve it is nothing but DPI goal XOR. Okay. So let's start with an easy example, lovely people. This is your array. K is equal to 3. You want to calculate dp1 of 2. dp1 of 2 means what? dp1 of 2 means what? That you are considering this much part of the array. Means you are fixing the first element of the array. Fixing the first element of the array, you are fixing the first element of the array. Such a nice, lovely thing, right? Fixing the first element of the array and making sure that its XOR value is 2. Making sure that its value is 2. So guys, please tell me which number if you put here the value will become 2. dp12 means fix the first element in such a way such that its value become 2. So instead of 1 I have to put a 2 here. This is index 1 and I have to put 2 here. That is the meaning of dp12. dp12 means at index number 1 the value should be 2. I know no one explained you in this way, but I am telling you the truth now. dp12 मतलब कुछ भी करके पहले इंडेक्स पे 2 का वैल्यू लाओ. तो कितना ऑपरेशन लगेगा ये करने में? dp12 is telling you that hey bro, for the first element of the whole array, can you make that value 2? Yes, I can make that value 2. But how many operations will it take? If you're trying to make it 2, you know now the cycle. This element will have to be forcefully equal to this element, will have to be forcefully equal to this element and this element. So total how many operations? Total number of elements in the cycle. There are how many elements in the cycle? 1, 2, 3, 4. 4 elements in the cycle. Minus the frequency of the element you are trying to make. You are trying to make it 2, the frequency of 2. So you can see that 2 is coming only 2 times. So 4 minus 2, 2. 2 operations you have to do basically. One, you have to make this number 2. One operation is going here. One operation is going here to make this guy 2. But when you are making I equal to 1 as 2, now you have also have to change this 10th element. You have to make this element also as 2. So total 2 operations. That's why 4 minus 2, 2. 4 is the total number of elements in that cycle starting at I equal to 1. And then subtract the frequency of 2 in that cycle. So these guys are already 2, so no operations to be made. So 4 minus 2, their frequency of 2 was 2. So 4 minus 2, 2. So dp12 is nothing but 2 guys. dp12 is nothing but what? 2. Now guys, before going forward in the video, now I want you to calculate dp1 of 3. dp1 of 3 means you are trying to fix the first element. Fix the first element. Try to fix the first element such that its XOR value is 3. So guys, if there is a single number, the number itself is the XOR value. So you have to put a 3 here. dp13 matlab index 1 pe 3 dalo. So the cycle is again looking like this. So dp13 is nothing but how many elements are in the cycle? Basically all these elements will have to become 3 if you are making the first element 3. I know you have now understood. The total 4 elements are there in the cycle. What is the frequency of 3 in the cycle? ये 3 को देख के frequency 1 मत बोल देना. You don't have to count that 3. The frequency of 3 in these cycles is 3 is not coming even a single time. So 4 minus 0, 4. 4 operations you will have to do. dp13 is 4 because you have to make this also 3, this also 3, this also 3, this also 3. And no number is already 3. So hopefully you understood it. So guys, you have understood how to calculate. See, I know that now you are smart enough to calculate dp10 to make the first number equal to 0. dp11 to make the first number equal to 1. You can use a simple hash map to do that, right? You must be doing basic hashing if you're watching my video. dp13, like if you do everything from the scratch from my course, this is very easy. Till dp1 of 1023. I hope you understood the meaning. dp13 means make the first element equal to 3. What is the minimum operation needed to achieve that in the whole array? dp11023 will tell you how to make the first element equal to 1023, and also to make sure that the whole cycle has 1023 values at the period of k. Okay. Now guys, if I keep on calculating, let's say I calculate dp2 also, and it can range from 0 to 1023, right? Yes. So guys, if for an array of size n and this k, I am able to calculate dpk of, let's say I calculate dpk0, I calculated dpk1 till dpk1023. Okay, let's say I calculated till here. What will be the final answer? dpk0 is the final answer, because this means that I was able to select the first k elements, and also I made their XOR value 0. I made their XOR value 0. dpk0 means made their XOR value 0. So what is the minimum number of operations required in the whole array to achieve this? That is the answer of dpk0. So how will we calculate dpk0? So guys, dpi goal XOR is the thing, but first I element of the array have been decided, and their XOR is goal XOR. Minimum changes in whole array needed to achieve it. Minimum changes needed to make sure till index I XOR of all elements is goal XOR, and the first I elements have been decided. So you need to know the minimum changes in the whole array need to achieve this feat. I will always go from 1 to k if we are assuming one based indexing, and XOR will always go from 0 to 63. Okay. Yeah, sorry guys, I did a little bit of mistake. It will not go till 1023. See, I said that this I value will go from 1 to k, right? But this value, j value, this will go from 0 to 2 raised to 6 minus 1, and 0 to 2 raised to 6 minus 1 is nothing but 63. So sorry, it will not go from 0 to 1023. It will only go from 0 to 63, which is even smaller. Wow. So hopefully you did not get distracted by that little mistake. Okay. So anyways, when teaching hard questions, these things can always happen, right? So your I will go from 1 to k, and the current jar possible will only go from 0 to 62 raised to 6 minus 1, which is 63. So how will you calculate DPI goals or? DPI goals or will be nothing but DPI minus 1 goals or XOR last element plus total number of element in the I cycle minus frequency of last element in the cycle. Final answer will be dpk0 means first k elements have been decided, and the XOR equal to 0, minimum changes to be done in the whole array to achieve it. So now guys, lovely people, listen to me. Let's say I am at index I. I want to calculate dpi goals or. How will I calculate this? Obviously, one for loop is running from 1 to k. Okay. Another for loop is running for the all possible goals or values. The goals or can be anything from 0 till 63. Now, how will I calculate DPI goals or? I will write one more for loop for it. How will I calculate DPI goals or? I can fix the last element. I can fix the last element. I can fix the last element. To calculate this value, guys, what I can do is either either you can put 0 at index I. In that case answer will be, see guys, if you want to know that what is the best way to make sure that the first I elements have been selected and the XOR of these elements is goal XOR. Okay, the XOR of these elements is goal XOR. Okay, so you can decide now which number to put at index I. So let's say you decide that I will put 0 at this index. I will put 0 at index I. Then what will be the answer? Then the answer will be the best answer till I minus 1 such that its XOR is goal XOR. It's a XOR is goal XOR plus okay, it will be DPI minus 1 goal XOR. Why? Because if this part is having their XOR as goal XOR, and this value you are putting as 0, so goal XOR 0, the total value will also be goal XOR only, na? Because goal XOR with this 0 will be again goal XOR. So for I elements, goal XOR would have been achieved, right? So the basic idea, I hopefully you got it, that if you put 0 at index I, in that case the answer will be dp I minus 1 goals. Or the best answer to the best, if you are able to, if you are putting 0 at ith index, then the answer is nothing but the best way to achieve the same goals or value in the first I minus 1 elements, because the goals or will remain unaffected when you do it XOR with 0 for the first I elements. Okay, now guys, what will be the answer if I try to put fixing either put 1 at index I, put 1 at index I, then guys the answer will be what? DPI minus 1. Now guys, I am saying that let's say the XOR of the elements from index 1, the XOR of the elements from index 1 to I minus 1 is, let's say, G. Okay, and at index I am trying to put a number 1. There can be many different cases. Now I'm iterating through all the cases. So let's say at index I try to put a number 1. I know that the XOR of the numbers from 1 to I minus 1, this is I minus 1. The XOR of this part is G and this number is 1. So what do I want? I want that G XOR 1 is nothing but goal XOR. Only then the goal XOR value will come na for the first I elements. It means that the G value will be nothing but goal XOR with 1. So basically ये G की वैल्यू क्या होनी चाहिए? ये G की वैल्यू होनी चाहिए goals or 1. If this G value is goals or 1, then you can put a 1 here. Okay. So if you know the best answer till I minus 1 such that its OR value is goals or 1, then you also know the best answer for DPI goals, or if you are putting 1 at ith index. Okay. It will be goal XOR 1. Okay. Like this guys, you will try all possible cases. You can put many different numbers now, so you will try to put all different numbers till put 63 at the ith index. I know no one will take the risk to explain you in such detail, but I will do you because I really love you. I know I want to have to make you successful no matter what. So Ram Ram, you understood this much. Such a great pleasure. Now guys, listen to me. One thing is still missing. One thing is still missing. Let's say at index I you are making it 1, right? So you are saying that DPI goals or is nothing but the best way to fix the first I minus 1 elements such that theirs or is goals or 1. Theirs or is goals or 1 plus the changes needed to be made in the cycle, you know ना, this will generate a cycle. अगर आप आई नंबर पे 1 डाल रहे हो तो इससे जो साइकिल जनरेट हो रहा है वो साइकिल के जितने भी एलिमेंट्स हैं उनको भी तो 1 करना पड़ेगा ना, उनके मिनिमम ऑपरेशन कैलकुलेट करना मैंने सिखाया था. If you are making index I, if you are fixing b of I as 1, then you have to take care of the cycle generated from index I. So that's why the final formula, lovely people, comes out to be that DPI goals or will be nothing but the dpi minus 1 and the last element which you have selected. Okay, fix fix b of I as last element, and last element can go from anywhere from 0 to 63. So dpi minus 1 goals or last element plus total number of elements in the I cycle minus frequency of last element in the cycle. So like this guys, if you do, the problem is solved. You can check the C++ Java Python code. Such a nice sorcery has happened here. First of all, you iterate through the elements, and you have to store all the cycle elements, right? मेरे कहने का मतलब क्या है ना, मैं आपको एक बार बता ही देता हूँ. ठीक है, समझो ये तुम्हारा एरे था. ठीक है, ठीक है. अब इधर आगे कोई बोलता है कि सर dp21 फाइंड करो ना. सर प्लीज फाइंड dp21 ना. दिस मीन्स दैट these two elements, for example k is 3. Okay, k is 3. This means that first two elements have been decided and their XOR value should be 1. So that XOR's value should be 1, right? So in the end, in here also I have to fix something. Now let's say I am fixing the last element as 3. Last element as 3. Let's say I'm fixing that b of 2 should be 3 in this case. So if I put b of 2 as 3 in this case, how will I achieve dp21? I can achieve it if I have with me dp1. I have fixed 3 here, right? 3 or 1. dp1, 3 or 1 is what? I think it is 2. So dp1 to do I have dp1 of 2? So basically dp2 of 1 is nothing but dp1 of 2 if I am making b of I as 3. सो dp1 ऑफ 2 मतलब क्या कि पहला एलिमेंट 2 होना चाहिए. हाँ, तो पहला एलिमेंट 2 होगा, दूसरा एलिमेंट 3 होगा, तभी तो इनका क्यूमुलेटिव और 1 आएगा ना बेटा. Hopefully now you understood. So dp21 means fixing the last element to some value from 0 to 63. We will try each value one by one, and once that is done, na dp of I minus 1 goal values or XOR value as last element value. 3 is the last element value. This one. बट जब तुमने इसको 3 बनाया, तो यू हैव टू मेक श्योर ना दैट ऑल दीज एलिमेंट्स आर ऑल्सो बिकमिंग 3. This also, when you are making this guy is 3, this also needs to become 3. So for this particular cycle now, you need to know the number of elements in the cycle minus the frequency of 3 in this cycle. That's why the answer will be dp21 plus dp12 plus the number of cycles, number of elements in the cycle minus the frequency of 3 in the cycle. That is the final formula. Okay, I know it's very complicated, but hopefully you understood what's happening. So dpi goals or is nothing but dpi minus 1 goals or plus total number of elements in the I cycle minus frequency of last element in that cycle. Okay, so I will write it here also, plus total number of elements in the I cycle minus frequency of 1 in that cycle, because all the future elements also have to change to 1, and don't worry, it will never overlap because you are only doing it from 1 to k. Once you reach k, you can stop because all the other elements have been decided. Okay, ram ram. So guys, just writing two loops, and the time complexity will be O of k into 63 into 63, which is feasible less than 10 raised to 8 operations in this case. Okay, you can check it out, the code also. You can see, first of all guys, na there are so many cycles. So I'm going from 1 to n and I'm doing mod k. because any element can be either in the, there can be only k cycles, right? How many cycles can be there? That this is common sense, right? If k is equal to 3, there can only be 3 cycles. This is the cycle number 1, cycle 1. This is the cycle number 2, and this is the cycle number 3. Okay, and it will go further. So cycle 1, cycle 2, cycle 3, total k cycles. So for each cycle I am storing those elements in the hash map. For this cycle, this element has come how many times, so I can directly get the frequency and total number of elements in the cycle when I need. Guys, declaring the dp value, right? Dp vector, 2d vector. Okay, dp k of 64, I going from 1 to k, goal value going from 0 to 63. Total elements for that I is n minus I by k plus 1. This you can easily get by the formula of Tn equal to a plus n minus 1 into d. This must be taught to you in your AP arithmetic progression when you were preparing for your 11th standard, 12th standard, 10th standard JE. Last element can be anything from 0 to 63. So let's fix each one of them. When this is the last element, what is the best answer? This. I will take minimum over all of them because I want to know the minimum changes. DPK0 tells you that the first k elements have been fixed. Their XOR has been made 0, and you know the minimum number of changes need to be done in the whole array to achieve this. And the problem has been solved. And guys, the Java Python implementations can also be found there. So hopefully you guys enjoyed this session. Ram Ram.